Do you think that this ping pong ball will fall down if I place this inside this funnel and blow air into this? Let us see what happens. The ball is not falling down. I will repeat. Let us see. It's not falling down. So what is happening here? This can be explained with the help of conservation of energy principle. When you are considering the total energy contained in a moving fluid, we can see that the energy is distributed in the form of kinetic energy, then potential energy and pressure energy. Let us analyze the situation with a schematic. Here you are blowing air into the system, and when the air comes to this portion, you can see that the ball is blocking the passage. As a result, the velocity in this region will increase based on continuity principle. Here, when the velocity increases, the total kinetic energy is increasing. When total kinetic energy increases, the total pressure energy should go down based on the conservation of energy principle. So a low pressure is created in that region. As a result, the ball will get sucked into that portion. That is the reason why the ball is staying there. So it doesn't matter how fast you are blowing, the faster you blow, the ball will get sucked to that portion in much stronger force, because the atmosphere is always pushing, because atmosphere pressure is higher compared to this portion. Now I will show you one more experiment to demonstrate the same concept. Here I have a ball and a jet. If I hit this jet into this ball, if I place this ball inside this jet, let us see what happens. You can see that the ball is floating. The same principle is applicable here. So when you are increasing the velocity, the pressure will reduce, a low pressure region is created around that ball. As a result, ball is stationary there, or ball is floating, because nearby or the ambient pressure will be atmosphere pressure, and that is much higher compared to the pressure around the ball because of this air jet. So this principle, or when you are applying conservation of energy principle to a moving fluid, we call it Bernoulli's principle. When you are applying to an ideal fluid, we call it Bernoulli's principle. Now, if you wish to learn concepts like this so that you can experience science when you are studying, and you can stay away from rote learning or by hearting, and you can retain the concept for a longer duration, if you wish to join our free demo sessions for class 9 and class 10 foundation course, you can book your slots.